And hi, welcome back OpenFOAMers or YouTubers to our pimpleFoam discussion. In the last video, we were running the pimpleFoam file, and in this video, we have finally finished it. And these are the results if we use ParaView to view. Basically, we have our usual velocity profile up here. I selected the 1000 second, and then we have our entrance region here, as we've seen in our last pimpleFoam videos. And then the velocity profile develops once it reaches the end of the pipe. If you were to use the slice filter, basically we have add filter, common, slice. Okay, we will get this. We'll get the slice filter, and we select velocity. And then I click it away. I click away to remove all the extra stuff I don't want to see, like all those grids and the lines that I don't want to see. We can see the clear entrance region here, and the exit region is here. Very similar to our old pimpleFoam results. And if you were to look at the log, pimpleFoam log, we see that it took about 17,000 seconds to finish, which is about a few hours of simulation time. But for all intents and purposes, it's a very good run of our pimpleFoam simulation, all in all. So we have the snappy hack smash run, and then we decompose the thing. And then we have pimpleFoam running for this long and reconstruct parallel to get back our time profile. Okay, so this is our pimpleFoam file, and actually what I did halfway during the run is to kind of get a snapshot halfway through our pimpleFoam running, you know. Okay, so pimpleFoam snappy pipe, this is on my GitHub, so dismiss this. Basically, I have up to 400 seconds of runtime, so it's running halfway during the parallel simulation. Now, I mentioned before, I would like to discuss a little bit, besides the pimpleFoam results, which are pretty much okay, we can kind of tweak the simulation time to either speed up or slow down the simulation. We can even run the pimpleFoam as pimpleFoam. If we set the algorithms correctly, using one outer loop and 2 inner loops per time step. But of course, then we can use the Coulomb number more than 1. But anyway, yeah, we run up to a Coulomb number of 10 and all. But we wanted to see what happened if, the computer runs into an error halfway, and then we are left with this kind of a situation where we are halfway running our parallel case. And if we take a look at the log of pimpleFoam, oh, it's too big, so I can't see. Yeah, we take a look at the log pimpleFoam. It runs up to about 400 seconds of runtime, simulated time anyway. And then you have the processor 0, 1, 2, and 3 up to 400. And then, okay, this is what you're left with if the computer, for whatever reason, the simulation for whatever reason stops halfway, and then you're left hanging. How do we continue the run from this state? So that's a very important thing to take note of. So first thing first, I would like to copy whatever's in this folder, and I want to shift it to the root directory. Okay, so that's just to save everything there in case something goes wrong. Okay, so I want to save up the file there. I'll clear the right hand side. So, oh shucks, I think I want to undo that. Okay, never mind. I can. Okay, let me remove all these files. This kind of went horribly wrong. So I'm just going to quickly remove a lot of things using the rm-r star command. So two star, 3 star, 4 star, 5 stars, 6 stars, 7 star. Okay, that should rm-r 8 star, 9 star, all star run star system constant pimpleFoam star refined star. So I didn't need to finish typing the name, but I'm just going to remove all the unnecessary files. Yeah, hopefully I did not remove more than I intended to remove. Okay. This is hold on here. So okay, just wanted to check if I over deleted some things. So this was what originally looks like. I removed all of this. I remove all of this, which I don't need. I want this, all my personal stuff. This, the full refined snappy pipe. Yeah, these two I want to keep. So these are the ones I want to keep. And let me put pimpleFoam snappy pipe complete. Okay. Oh, sorry, I forgot. Okay. So it's gonna copy and paste. So hopefully when I look at the home directory, there should be a clone file, a file that I've cloned over here, and that's finished. So very good. Okay, so now I want to clear everything up here, and what I want to do is let's do a git reset hard. So what this does is to reset the situation here to just like halfway through the parallel simulation. Okay. Okay, I think I want to remove the pimpleFoam directory and git reset hard, so that kind of pulls everything in from Git. So you see, I'm getting all these files in. Yeah. So I'm gonna fast forward this process. I'm gonna come back. I'm gonna take a break first. Wait for this thing to kind of settle in. Then you'll see what we can do from there. Okay. So now that is done, it basically just reset all the files to like halfway during the OpenFOAM run. So let's see processor 0. And take a look. It's only up to 400. So, and where's the pimpleFoam? So this is what happens. It just simulates what happens when we stop the simulation halfway. So let's go. So it's at time just about 400. You see, time equals 400 seconds of simulated time. And if we were to do pimpleFoam parallel, okay, we're going to run into some error. Alright, so we find an error. It says if you try and run pimpleFoam in parallel, you'll get this error, attempting to run parallel on one processor. So okay, now we have a problem. How do we get around this issue, right? How do we get around this issue? So, well, the trick is this. Basically, before before, how do you say, before OpenFOAM was run, I mean, okay, let's take a slow down and think. Before we ran this series thing, we ran a pimpleFoam in series. So let's say pimpleFoam stops at 400 seconds. Then you have the file from 0 to 400 over here in the main directory. And then we could continue running in series, no problem. So how do we restore ourselves to that state first? Okay, so normally we start, okay, let me use Paint. Okay, so we have a pimpleFoam or pimpleFoam. Piso or pimple. Foam. So what we have is an initial directory 0 and some the mesh parameters which are in the constant file. Okay, so 0 and the mesh parameters are there. And what happens during a series? In series, oops, excuse me. Yeah, in series, in series we will have this situation where 0 is being zero is being moved forward. Okay. So you have 0 going to like let's say the timestamp at 50. Then OpenFOAM is going to take the timestamp 50 file. If you're going to continue from 50 seconds, you go to 100. If we stop halfway, let's say the run is at 1 through 3 seconds, OpenFOAM will take the 100-second data and it will continue running all the way to 150. That's if our timestamp interval was 50 seconds. Now, parallel case is slightly different. Parallel case, you have decompose. You need to decompose. Alright. Now decompose parallel, and then it will go into 4 processes. So basically, each of these processes will take up one part of the mesh, and each will go into 50 and go to 100. And let's say you stop at 100. Okay. How is it going to continue? Well, basically one workaround is this. We can get to this this kind of setup where we have 50. We reconstruct from the parallel processes back into like a normal series kind of processing, where we have the full data for 50, full data for 100, and after that, what we can do is to redecompose. So redecompose back into our 4 processes, and then we start going from there. So that is the aim of what I'm trying to do here. So I want to try and reconstruct from all these what do you call that, processes back into the let's say back into like a series kind of format. Meaning to say, if I was running pimpleFoam in series, what will be the output file? I would see 0, 50, all the way to 400, 0, 50, 100, 150, 200. These are the time steps all the way to 400. But now all I have is the time steps in the processor, and I'll need to get all this data out first. Okay, so let's see what is normally being done. Let's say we have an all run parallel. Okay, so normally we have this case where we restore 0 directory from the original, we decompose parallel, and we force it, meaning to say if there are any parallel directories there, we delete all of that, and then we run parallel pimpleFoam. And then we run the application called Reconstruct Parallel. Okay. Well, let's try that. Okay, we take a look at the run folder. Okay, this is running in series. This is what you normally get. Then we have a run parallel. So we should have a simple template for that. Restore 0 directory, run application decompose par force, and then we run parallel pimpleFoam. Okay, so let's make a copy. cpar run parallel, and we want to have it as run continue run parallel. So what will we put in this script? Vi continue run parallel. So okay, what are we supposed to do? We want to remove the restore 0 directory, so we want to run reconstruct parallel first. So usually we have this reconstruct parallel. Then we want to decompose it, force a decompose parallel, and then we run parallel pimpleFoam. Then we run the application reconstruct parallel again. Let's see what happens if we were to take this course of action. So go to save and quit. Okay, continue run parallel. So let's see what happens. The GitHub, and let's go to thin pipe flow and pimple. So you see all the files here are being reconstructed. That's what I'm doing. So okay, now we have some things happening. Let's take a look at the pimpleFoam. Okay, pimpleFoam is running, which is great. So decompose parallel is already run. Okay, vi log.pimpleFoam. So basically the thing is able to run. So it's running a few pimple iterations already. So I see the time is 4:02 now, which is great. Okay, so what this shows us is that we don't need to go through the whole process of decomposing. All we need to do is to reconstruct parallel, this one, reconstruct par. Okay, we just need to do the reconstruct parallel for this, and then once you have both of these files in the 100, you know, the 100 time step, let's say the 400th time step, for example, I have it in series format, which is the format I'm talking about here. I have it in the main directory, and then what I want to do is to redecompose it back into the parallel directories. But you see, if we take a look in the parallel directories, okay, if we were to do what we originally intended, this will be the steps you get. Okay, so let's say you are at the 400 time step. Okay, this is the parallel, this is the series. Now what I originally intended to do was to reconstruct here, reconstruct parallel here. Okay, and then I wanted to force a decompose with a force. Okay, what does this do? This will delete all of the existing files, and then it will create a new parallel file from 50 all the way to 400 in the processor directories. So for all intents and purposes, this is a pretty redundant step. Okay, redundant because we have all the files we need already. So this is a redundant step. We don't really need this. So we can actually do away with that step. But actually this code actually works just fine. Okay, if you take a look at the log pimpleFoam, everything's working nicely. Okay, so to continue the run, it's actually pretty simple. If we have the processor directories and we don't have all of these directories here, we will need to do a reconstruct parallel, and then we just run pimpleFoam in parallel as per normal. So we'll continue run parallel. We can rearrange the script slightly. Okay, so well, of course, if reconstruct par was run before, we will need to remove the previous log of reconstruct parallel. So we can just we can do that, or we can run reconstruct parallel in the background, whichever is fine, but I would prefer this. I mean, my personal preference is to run reconstruct parallel. Okay, and I want to do it to a log reconstruct parallel continuation. Okay, so this will make sure that the log that I run at the end of the day and this log is different. So yeah, so this will actually just delete the old pimpleFoam log, and you'll just continue from there. So this is what this script will do. It's pretty rudimentary, but it does the job. Okay, and this one is kind of redundant unless you want to run from a series case. That means I only have I mean, this is good if this is good if I only have these cases from 0 all the way to 400, and then I'm missing all the processor directories. And if I want to run a decompose parallel from a series, starting from a series case, and then I want to proceed on with parallel, I can use that script. Otherwise, it's pretty much the same. Okay, so I'm gonna stop this, and let's try running the script again. On the right side, so you see it will just run pimpleFoam again, and we take a look at the log.pimpleFoam. It does very nicely. So this is basically the trick. Yeah, this is basically the trick for running processes in parallel. If for some reason, for whatever reason, your computer or the pimpleFoam, whatever, stops halfway, so you need to do this little thing to help it to continue onwards with a parallel run. So I'm gonna save this. I'm gonna do a git add. Okay, so it's gonna add all of these things in. Okay, git commit with message continue parallel running script created. So that's what it's doing. Very simple. Okay, so once that is done, we can push it up to Git, and that's basically it. So in this video, we went through the pimpleFoam results, which were pretty much the same. Nothing too much of note. Nothing too much of note for our directories. Nothing too much of note for the pimpleFoam case. We just know how to run pimpleFoam now, and we know how to continue running pimpleFoam or pisoFoam, whatever, in parallel. If for whatever reason we have an error and something goes wrong halfway, how do we continue running in parallel after that? So this video actually demonstrates how to do that. So thanks for watching. I'll see you guys next time.